So again, good evening, guys. So we are going to start right now. So yesterday we did in the previous class, we did about all of these basic refraction. Okay, what is called as refraction, what is going to happen, light vector, and all of these kind of things we did. Okay, but right now, what we are going to do, we are going to basically understand what is this Snell's law. Okay, means we know that Snell's law जो भी हमें बताया गया था in class 9th and 10th, 11th also, like 12th, not in 11th but in 12th, and in optics like Azoy we have gone through this Snell's law. But actually this Snell's law, it is not limited to that only one formula, that sine theta mu1 of sine theta 1 is equal to mu2 of sine theta 2. So it's not related to that only. It has a very big form, and we are going to study basically that only. Okay. So to study about that, basically to understand what is going to happen with the Snell's law और Snell's law में क्या होगा, उन सारे चीजों को समझने के लिए हम पहले थोड़ी छोटी छोटी बातें समझेंगे, ठीक है ना. सो गोइंग टू स्नेल्स लॉ, तुम एक बात बताओ, अगर हम नॉर्मल स्नेल्स लॉ बताते हैं, नॉर्मल स्नेल्स लॉ क्या बोलता है कि लेट सपोज अगर एक इंटरफेस है, ठीक है, इंटरफेस क्या है, ये तुम्हारे पास एक इंटरफेस है between two mediums. Let's suppose this is medium 1 and this is medium 2. Medium 1 की refractive index है mu1. Let's suppose the refractive index of medium 1 is 1. Refractive index of medium 2 is what? Mu2. Now, let's suppose if the light is entering from medium 1 to medium 2. What is happening? Light is entering from medium 1 to medium 2 in such a way that medium 2 is having higher refractive index as compared to the medium 1. Got it or not? What I told? Let's suppose you are having such this medium 1 is lesser refractive index than medium 2. So what is going to happen? This will be called as angle of incidence I, and this will be called as angle of refraction R. So what does Snell's law tell? Snell's law tells only one thing, that mu1 of sine theta 1 should be actually equal to mu2 of sine theta 2. How is it this possible? How is he saying that? So he took one component. Let's suppose this is incident ray, and let's suppose the component of incident ray along this horizontal direction is how much? In this horizontal direction is how much? It will be angle of I sine theta I into refractive index mu1. It will be the component of incident ray along this horizontal axis or not? Tell me yes or no. We know that this is, if the theta is attached to the, let's suppose in this triangle, if theta is like this way, so this is what I can write the base as hypotenuse into cos theta, and I can write the perpendicular as hypotenuse into sin theta. Are you aware of this thing or not, everyone? Yes or no? छोटी छोटी बातें, yes or no, guys? Hello, Himanshu, Gagan. Okay. Yeah. You have to tell me yes. Himanshu, Gagan, Saloni, you have to tell me at least yes or no. Okay. So now look over here. So for this theta r also, if this light is coming towards this side, what is going to happen? It will have again a horizontal component. That will be how much? Angle of r mu of 2 sine, or I cap you should write, or r cap mu2 of sine theta r. Okay. So this is the relation. Now we know that along this horizontal component, like the right side horizontal component should balance with the left side horizontal component, and that is why you get the first Snell's law, and that is equal to mu1 sine theta 1 is equal to mu2 sine theta 2, or mu1 sine theta I should be equal to mu2 into sine theta r. Got it or not? So this is the relation that Snell's law followed, and which you have learned till now. But the question is like, what if happens, like what if the incident ray is not in the plane in which this normal is there, and like what if happen if the incident ray has different directions or something like that? So at that case, what is going to happen? Your answer will change directly. To basically understand about that, we are going to talk about the vector form of Snell's law. Okay. So it is basically based upon the second law of refraction. Means second law of refraction means what? That this mu1 sine theta 1 should be equal to mu2 sine theta 2, or that Snell's law tells na that sine theta 1 by sine theta 2 should be equal to a constant factor. Okay. So based upon that, this refraction, this particular vector form of Snell's law, we are going to form over here. What does it tells? So let's suppose if incident ray is there. Okay. Now this incident ray can be represented by some vector I cap. So I am representing incident ray by a vector I cap. Now this particular normal over here, this particular normal, I can represent this by n cap. Okay, so I'm representing normal as E of n cap. Got it or not? How I am representing my normal as E of n cap, where upward and like up above the interface it will be positive, down below the interface it will be what? Negative. Are you able to get me or not? Are yes or no? Okay. Now, hi Mansu. हाँ कॉस देखो हिमांशु ने बहुत अच्छा क्वेश्चन पूछा कि सर यहाँ पे ये जो कंपोनेंट है कॉस कंपोनेंट हम क्यों नहीं यूज कर रहे हैं? सो देखो यहाँ पे म्यू वन कॉस थीटा आई या म्यू टू कॉस थीटा आई। एक बात बताओ सीरियसली, देखो क्या होना चाहिए, तुम एक बात बताओ। अगर इंटरफेस पे लाइट ट्रैवल करेगी, लेट सपोज इफ द लाइट इज ट्रैवलिंग ऑन दिस होल इंटरफेस, द वेलोसिटी शुड नॉट चेंज और नॉट? टेल मी हिमांशु, यस और नो? The velocity of light should not change now. But if the light travels from this particular, let's suppose it is in this region, then it is entering into this region. What will happen? Let's suppose it has v1 here, it has v2 over here. What will happen? Velocity v1 will not be equal to v2 or not? Tell me yes or no. Along the cos component, tell me. That is what is the basic principle of refraction or not? So what remains same along the horizontal axis? Velocity over here, v1 and v2 component along the horizontal remains same or not? That is why you are taking mu1 sin theta 1 to be equal to mu2 sin theta 2. Are you able to get me or not now? Got it or not? So it's related to mainly velocity. That since velocity component is equal in the grazing means at the interface, that's why we are taking that mu1 sin theta 1 is equal to mu2 sin theta 2. While if the like look over the vertical component, since the light is entering from one medium to another medium, what is going to happen? Velocity is going to change. That's why you are not taking mu1 to be equal to, like you are not taking mu1 cos theta to be equal to mu2 cos theta r. Got it or not? That is the biggest difference. Okay. Okay. Now coming to this point, now you try to see what I have done. I represented my incident ray by I cap. I'm representing my normal, this particular normal as En cap. Okay. Now what is going to happen? This interface will also have some kind of vector. I can represent this particular interface. See this. This is a medium interface where, like, let's suppose this is medium one and this is medium two. Medium one has refractive index mu1. Medium two has refractive index mu2, where mu2 is greater than mu1. So this particular mu1 between mu1 and mu2 there is an interface. Okay, and I can represent this interface by some vector. Okay, and I call this vector as what? Interface vector. So I'm representing this interface vector. Let me be fast a little bit. Interface vector as q cap. Word or not? कुछ ज्यादा नहीं हुआ अनुज, ठीक है ना? तो मैंने क्या किया? I told like incident ray has some most importantly try to understand this, that I'm representing all of these things in terms of unit vectors. Why? Unit vector shows the direction. Incident ray we can't say about the magnitude of the incident ray, so that's why we are trying to convert it into unit vector form. So let's suppose incident ray is denoted by unit vector I cap. The direction of incident ray is shown by unit vector I cap. The direction of normal is shown by En cap, and the interface direction is shown by Q cap. Got it or not? Now what is going to happen? This refracted ray also, the refracted ray which is going inside the medium, can be also represented by some kind of unit vector. So I am representing my refracted ray by an unit vector of r cap. Got it or not? Are you able to get me or not? So all of these notations I have made it clear. So four notations are there. First incident ray I cap, second normal direction En cap, third the interface vector that is Q cap, and then last refracted ray which is represented by r cap. Got it or not, everyone? Are you able to get me or not? Okay. Tell me. Interface vector means, see, like interface vector means we are trying to represent the plane of the interface by some unit vector. Got it or not? Okay, so this interface has some plane over here or not? Tell me yes or no. This is like plane of the light ray. The particular vertical plane which light ray makes with the normal is called as plane of incidence. But this particular even interface is going to have some kind of plane or not. Tell me some. So we are representing the plane of the interface by some kind of vector q cap. Got it or not? Okay. So now look over here. All of this, if I have formed, what is going to happen? Let's suppose if you are aware of incident ray and if you are aware of this normal. So look over here. Let's suppose if you are aware of this I cap, or if you are aware of some kind of, so there are some steps. Okay, I'll just minimize this and I'll write those steps. Okay. Wait. Okay. So let's suppose you are aware of incident ray vector. Incident ray vector is given. Okay. So first tell me, let's suppose if incident ray vector will be given, can you know the particular normal vector? How to form, how to get the normal vector? Simple. Look, let's suppose if incident ray is given in XYZ plane. So what, in which direction the normal will be? You can consider that the whole, this whole axis can be represented as this as Z axis, this as Y axis, and this as X axis. Got it or not? So we can consider that the plane of the interface is lying in XY plane, while the Z axis, the normal is lying along the Z axis. Got it or not? So that will make your question easy. So we can consider that En cap is represented along one of the axes, along one of the axes. Got it or not? Now, how to find after that interface vector using the incident ray? Easy. How we can get it? Now, let's suppose this plane, you try to understand, this plane of interface is actually perpendicular to the plane of incidence ray or not? Tell me yes or no. Everyone? This plane of interface, Gagan, Anush, Saloni, and Himanshu, tell me, this plane of interface is actually perpendicular to the plane of incidence or not? Yes or no? Okay. So if it is perpendicular, so let's suppose if you subtract the normal component of incidence ray and taking its unit vector will give the direction of interface. The direction of interface. Are you able to get me or not? What I told that, see, simple. First thing, if you get the incident ray equation, then you can easily calculate the normal. You can consider it to be along any of the axes. If you get the normal direction or normal component, then what you do? From the incident ray, subtract the normal component. You will get definitely what kind of what kind of vector you will get a vector for the interface. Then you take the unit vector of that equation and you will get what? Interface vector, or you can call as plane of interface vector. Are you able to get me or not? Till this point, is it clear or not? समझ में आया कि नहीं आया बताओ? अनुज, गगन, सलोनी, हिमांशु. गगन, अनुज, समझ में आ रहा है? ओके, चलो तो अब और आगे हम बढ़ते हैं. यहाँ पे 4 पॉइंट हमने समझ लिया, ठीक है ना? अब देखो, जैसे ही तुम्हें यहाँ पे इंटरफेस वेक्टर मिल जाएगा, तुम्हें खुद you can also tell me, see this. You have got the interface vector which is represented by q cap. You will be aware of this normal vector which is represented by En cap. Now you know the formula that n1 sine theta 1 or mu1 sine theta 1 is equal to mu2 sine theta 2. If you apply this, what you will get? Here theta 1 will be, you will be aware of theta 1 and you are aware of mu1. Here you are aware of mu2, you can calculate the value of theta 2. As you get the value of theta 2, we can form the refracted ray equation or not. What will be that refracted ray equation? That will be how much? Can I say that refracted ray equation will be cos of theta, let's suppose if I'm representing theta 2, cos of theta 2 into En cap plus sine of theta 2 into q cap. Can I see this? can I say this, that the refraction equation, that the refracted ray equation will be like this way? Everyone, are you satisfied? Are you satisfied with this or not? See this. What is going to happen? You know that refracted ray has two components, one along the normal, which is represented by cos, one along the interface, which is represented by sine. So cos theta 2 into the direction of normal will give the component along the normal, and sine theta 2 into the q cap, it will give you the component along the particular interface. Yes, Gagan? Uh, yeah. Yeah. So it will be like, okay, you can, but actually, if you write En cap, when you will be writing En cap, then only you can write the negative sign or not. Tell me yes or no. The direction of En cap when you will be writing. Gagan? So actually, when you will be writing En cap, at that time you can write the negative sign or not. Tell me yes or no. So the direction of this normal direction you can represent by negative sign over here. Okay, and at that time you can write it in a perfect way. Okay, so it's not a problem. Negative sign is just showing the direction or not. Tell me yes or no. So you can write you can write the particular equation out of it. Okay. So this is the whole equation. See, so if I am aware of incident ray equation, we can calculate the refraction equation without using the Snell's law and all. Okay. So how to write it? It is equal to cos theta 2 of n cap plus sin theta of q cap. The point is, in this equation you try to observe that these all involves unit vectors. They are not involving any kind of magnitude over here. We have taken the magnitude for all of these possible cases to be equal to 1. So that is why we are only considering the direct sense. Okay, now this kind of particular theorem will be applied when you will be aware of incident ray equation. Remember that when incident ray equation is not given, this theorem is not of any kind of use. Okay, so based upon this I'm trying to give you one question. Will you try? Will you try, guys? So look over here. Okay, so let us give me one question. What is that? That let's suppose if incident ray equation or incident ray vector is given. I'm not saying that incident ray unit vector is given. Incident ray vector is represented, and it is given as 6 root 3 I cap plus 8 root 3 j cap minus 10 k cap. Okay, so this is the incident ray. It is the incident ray vector. Okay, the question is, let's suppose for a z greater than 0, if mu is given as root 2. Okay, for z less than 0, the mu is given as root 3. The question is, find the unit vector for the refracted ray. Sorry, find the unit vector for the refracted ray in the second medium. Can you do it? Easy? Yes or no? Try to do it. Do it fast. Do not take more time. Incident ray vector is mentioned. Now, one thing also I am mentioning, that the interface is lying in xy plane. Do it fast. Okay. Utilize this particular diagram. Okay. Tell me, Gagan. Yeah. Again, actually, that's what I told now. If normal things are not going to be applied, normal concepts are not going to be applied, we need this vector form, correct or not? So that's why we are ignoring all those facts. Okay. Are you able to get me or not, Gagan? It's just like that reflection case, okay, where the same plane formula just it's in the same plane only, but little bit of change is there. Okay, first thing I'll try to solve it little bit. First, I'll just make you guys understand. Okay, so I'm erasing little bit of this part. Okay, so that I can do the questions properly. Okay, so look over here. Try to see this. First thing, where is the direction of normal? En cap. En cap represents the direction of normal. It is along the positive z direction. Yes or no? Look over here. For z equal to 0, you are given the refractive index. For z less than 0, you are given the refractive index of the material. So that means what? Particularly z axis is along the normal. So normal is represented by k cap. Got it or not? Now look over here. What is the component of normal in the incident ray? See this component of normal in the incident ray. Look over here. What is that? See, incident ray is represented by this vector or not? 6 root 3 I cap plus 8 root 3 j cap minus 10 k cap. Now, what is the component of the normal in this particular incident ray? This term, this 10 k cap minus of 10 k cap is the component of normal in this particular incident ray or not? Tell me yes or no. Saloni, Gagan, Himanshu, Anuj, yes or no? Tell me. How? Array, simple. If let's suppose if vector A is given and if someone asks you what is the component of vector A along some another vector B, what you are going to do? You are cos theta. You are just going to take A dot B. It is going to give you the component of vector A along vector B divided by modulus of vector B. Sorry. Okay. So this is going to and again modulus of vector A. So this is going to give you what it is going to give you. This term is going to give you how much component of one vector along another vector. समझ में आया कि नहीं आया है ना? So this for this only dot product is there ना? That dot product says this thing that you can calculate the component of one vector along another vector. So now look over here. What is the component of one vector along another vector? I asked you what is the component of normal in this incident ray. So it is that term which is along the z axis. Since z axis is represented by our normal, okay. So therefore the component of normal in the incident ray is minus of 10k cap. So that is equal to minus of 10k cap. So what is your second step? Look into this particular second step is what? Subtract the normal component of incident ray and taking its unit vector will give the direction of interface. So to find the direction of interface, to form the refracted ray equation, we need what? This direction of the interface. To be aware of that, what we need to do? First, take your particular whatever wait. First, form q vector because incident ray is a vector quantity. So form q vector. Q vector will be what? Vector A. After that, minus of component of normal. Okay, means incident ray minus component of normal. Okay. So if I subtract the normal component, what I'm going to get? I'm going to get q vector as or interface vector as 6 root 3 I cap plus 8 root 3 j cap. Are you able to get me or not? Yes or no? Saloni, Gagan, Himanshu, Anuj. Are you able to get me? 100%. Anuj, समझ में आया कि नहीं आया? Hello? Okay. So first, as you are aware of this particular which vector, you are aware of your interface vector. I can convert this. I need to know the direction of this interface. So I will have to write the q cap. Q cap is going to be how much? 6 root 3 I cap plus 8 root 3 j cap divided by root over 6 root 3 whole square plus 8 root 3 whole square. Got it or not? If you do this, what you are going to get? You are going to get your q cap. How much is this going to be? After solving, I'm not going to solve all the procedure. I'm going to write directly the answer. It is equal to 3 by 5 I cap plus 4 by 5 j cap. Got it or not? Can you solve this or not? Tell me yes or no. You can easily solve this. Okay. Now look over here. As you are aware, now you are perfectly aware of this interface also. You are perfectly aware of this interface. But what you are not aware of? Are you aware of this angle of theta? Means what is the angle this incident ray is making with the normal? No, no. Can you calculate it or not? Tell me yes or no. So with I can calculate. Yeah, cos theta I we can calculate how by taking the incident ray. Okay, so let's suppose this is my incident vector. So incident vector dot normal cap en cap, okay, divided by modulus of vector A modulus of en cap will give you what? The angle made with the incident ray with the normal. Yes or no, everyone? Yes or no? Gagan, Anuj, Saloni? ये फॉर्मूला कहाँ पे है? ये फॉर्मूला तुम्हें डॉट प्रोडक्ट से मिलता है भाई. ये फॉर्मूला है, मतलब फॉर्मूला सोचना पड़ता है. नहीं, एक बात बताओ, मान लो क्वेश्चन तुम लोग मींस रियली you guys have very weak basic concepts. Okay, now look over here. Let's suppose if this is theta, if this is if this is vector A and if this is vector B, if I want to calculate, if someone asks you what is the component or what is the angle theta over here, what it will be? Theta I can calculate in a simple way. A dot B divided by modulus of vector A into modulus of vector B. How simple is it? So that's what I'm doing. Incident ray, I know the incident ray vector. I know the normal vector. So if I want to know the angle between them, I'll just apply the dot product over here. Now, incident ray vector is given in 6 root 3 I cap plus 8 root 3 G cap minus 10 K cap. So what it will be? Minus of 10 K cap dot K cap. Yes or no? So what it will come in the numerator? It will be minus 10. Now, what is modulus of it? It will be root over 6 root 3 whole square plus 8 root 3 whole square plus minus of 10 whole square, and that is going to give us cos theta of I. Now you can ask me, sir, why you have taken modulus of en cap as 1? Simply en is like this is representing a unit vector along the normal, so magnitude of unit vector is always equal to 1. So therefore cos theta is equal to minus of 10 divided by root over 6 root 3 whole square plus 8 root 3 whole square plus minus of 10 whole square. Got it or not? This step, or yes or no? Simple. Now look over here. What you are going to get this as? This is going to be cos theta is equal to minus of 10 divided by root over 400. This is going to be minus of 10 by 20. And you got second term, that is cos theta I is equal to minus of 10 divided by 20, which is equal to minus 1 by 2. Now from this I got theta I as how much? 120 degree. But one thing is there. Now comes the point. Now again logic. Who will explain me that if I say that the angle of incident made with the normal as 120 degrees wrong, then what is the correct answer? 60 degree. What is the angle? 60. Yes or no? Why? You try to see this. Incident ray is pointing downwards or not? Tell me yes or no. So for the downward vector, you got angle to be equal to how much? 120 degree. That means what? Actually, you have got with the minus z axis, this angle you have got. And that is equal to how much? 120 degree. So to be aware of this angle, this theta, it should be how much? 180 minus 120, and that is going to be how much? 60 degree. Got it or not? So therefore, actually, looking at the figure over here, okay. So what is the angle of reflection, angle of incidence over here? Actual angle of incidence is how much? It is equal to 60 degree. Are you able to get me or not? Gagan, Anuj, Mansu, clear है अभी? No, Gagan? Hello, Gagan. समझ में आया ना तुम्हें? अनुज, अनुज, अनुज. Okay. गगन, तुम्हें समझ में आया? सलोनी, तुम्हें समझ में आया कि नहीं आया? हेलो, सलोनी, वेर इज सी? भाई साहब, एकदम से सिंपल सा पॉइंट था. सिंपल सी बात है, नोटिस करो, इंसिडेंट रे इधर की ओर पॉइंट आउट कर रहा है डाउनवर्ड. अरे यार, फिर से बताना पड़ेगा. देखो, इधर देखो, जब इंसिडेंट रे इस तरह से जा रहा है, ठीक है, incident ray is pointing downwards, you know the equation of these. So you can represent this incident ray like in the forward direction over here. Yes or no? This will be mainly incident ray direction. When you are taking the dot component with the positive axis of en cap, what you are doing actually? This en cap is pointing over here. So actually you are taking the calculation or you are doing the calculation for this path. Yes or no? And you have calculated this path as how much? 120 degree. When you have calculated this 120 degree, this is going to be how much? 60 degrees. Simple. Yes or no? So now look over here. So here angle of incidence made with the particular angle of incidence made with the positive direction of normal is going to be how much? 60 degree. So now you are, Gagan, tell me. Huh, normal vector, yes. नहीं नहीं नहीं. What? Okay, so look over here. Simple. देखो ये गगन en vector is the direction of normal or not? So en vector is no. En vector is just equal to k cap. Look over here. En vector is representing what? The direction of, yeah, yes. Array, listen me. What I have told, that the component of normal in the incident ray is equal to minus 10 k cap. I didn't have told that En vector is representing some kind of this value. It is saying En vector is what? Look over here. See this. What does it represent? It represents the normal over here. In which direction the normal is going to be, that is going to be represented by my what? En vector. Now here, try to see this. This is my normal. Normal is pointing along the positive z axis. So this positive z axis is represented by what? Your unit vector, and that unit vector is which one? En cap. Now En cap will have how much like for what value it will be equivalent? It will be just equivalent to k cap, because z axis is just represented by k cap. Are you able to get me or not? Okay. हाँ हाँ. नहीं. एक एक बात बताओ. तुम तुम पहले तुम खुद सोचो. पहले ये जो नॉर्मल जो है, वो इंसिडेंट रे के ऊपर थोड़ी ना डिपेंड करता है. वो तो इस पॉइंट के ऊपर जहां पे फॉल कर रही है लाइट, उसके ऊपर डिपेंड करता है. The point where the incident ray is going to fall on this normal is going to be dependent upon. It is not going to be dependent upon your incident ray itself. Okay, the equation of incident ray is not going to tell anything. It is just going to tell that how much component of incident ray is going to lie along the normal. Got it or not? Okay, so now next point is, see this. I have taken incident ray is pointing downwards. So actually, since incident ray is pointing downwards, I should have considered here minus of a vector over here. Okay, but I didn't have included that. Why? Because to make my question easy. So therefore, I got cos theta as negative minus 1 by 2, and that's why I considered that this angle I have got as cos theta I, it means theta I, and that I have got as 120. So this normal incident angle will be how much? 60 degree. Got it or not? So all the steps, look little bit logically, look at all the steps. Okay, so here theta if you got how much, it is equal to 60 degree. Yes or no? You are aware of the normal vector, you are aware of the now which vector? Interface vector. So you can easily form your reflected vector or refraction vector, sorry, as what? It will be how much? It will be cos of theta. Okay, wait, first thing, now, as we know our incident ray angle, now we need to know refraction angle. So what to apply? Apply Snell's law over here now. Applying Snell's law. And this Snell's law will give what? Mu1 into sine of theta I is equal to mu2 into sine of theta R. Now mu1 is given how much? For z greater than 0, mu1 is root 2. So root 2 into sine theta I, sine 60. Mu2 is given how much? Root 3 into sine, how much? Sine theta R is given. Theta R is going to be how much? You need to calculate. So root 2 sine 60 is equal to root 3 sine theta R. what you will get, you can look over here, sin 60 is root 3 by 2, root 3 will get cancelled, and what you get over here, 1 by root 2. So that means what? Theta r is going to be equal to actually 45 degree. Got it or not? Yes or no? What? हाँ, ये सारा चीज अभी बस थोड़ा सा है. म्यू1 स्नेल्स लॉ क्या बोलता है कि म्यू1 sin थीटा 1 is equal to म्यू2 sin थीटा 2. बस सिंपल सी बात है. Now look over here. After going through this, theta r is going to be how much? 45 degree. Now, as I am aware of the theta r, we calculated my refraction angle 45 degree. We can form the refracted vector, like equation of unit vector for refraction. What that will be? It will be cos of theta r n cap plus sine of theta r q cap. Now, what is cos of theta r? Cos of 45 degree. En cap is what? Minus of z axis. Here in downward direction, look over here. Karan asks the same thing. Sir, where is the negative sign? Here it is, negative sign. Got it or not? So normal is pointing downward for the refraction ray. That is why minus of k cap plus sine of 45 into q cap. What you have got is your q cap. It is equal to 3 by 5 I cap plus 4 by 5 j cap. Got it or not? Now, can you form the refraction angle from here or not? Or refraction, like equation for the refracted vector? Yes or no? Yes. Easy. Anuj, Gagan, yes or no? Huh? Huh. Yeah. Yes, Himanshu, you were asking something? ये है तुम्हारी क्यू कैप. ये जो इंटरफेस की जो वेक्टर है ना, ये जो इंटरफेस है ना, देखो ये इंटरफेस हो गया कि नहीं तुम्हारा. उस इंटरफेस को हम रिप्रेजेंट कर रहे हैं एक यूनिट वेक्टर से. डायरेक्शन ऑफ इंटरफेस हम रिप्रेजेंट करना चाह रहे हैं, एंड दैट इज रिप्रेजेंटेड बाय क्यू कैप. गॉट इट और नॉट? नहीं नहीं नहीं, उधर नहीं. ठीक है, जल्दी से लिखो इसको, कंप्लीट करो इन सारी चीजों को. कोई भी डाउट हो तो पूछो जल्दी से. सो यू नीड सम क्वेश्चंस. हाँ, सब्ट्रैक्ट करने से तुम एक बात बताओ, ये जो तुम्हारे पास जो इंटरफेस है वो सिर्फ एक्स वाई प्लेन पे लाई कर रही है कि नहीं लाई कर रही है? उसमें तो जेड का प्लेन का कोई कंपोनेंट नहीं है ना, तो इसलिए हम सब्ट्रैक्ट कर रहे हैं. हम जो नॉर्मल का ट्राई टू अंडरस्टैंड. ठीक है ना? हाँ, दैट जो प्लेन ऑफ इंटरफेस है उसके अंदर तुम्हारे पास नॉर्मल का कोई भी कंपोनेंट नहीं होगा. जो नॉर्मल का कंपोनेंट होना चाहिए वो जीरो होना चाहिए प्लेन ऑफ इंटरफेस पे, क्योंकि इंटरफेस जो है, प्लेन ऑफ इंटरफेस इज एक्चुअली परपेंडिकुलर टू द प्लेन ऑफ नॉर्मल. ओके, नॉर्मल एंड इंसिडेंट रे. So that's why you are subtracting that particular component. Gagan, Gagan, got it or not? Saloni, got it? Saloni, are you able to listen? अनुज, समझ में आया कि नहीं आया? आ ही गया मतलब, इसको जाके बनाओ, बिना दोबारा बनाए हुए नहीं समझ में आएगा, है ना? So can I move ahead? Should I move ahead now? So I'm moving little bit ahead. Okay. Okay. Now look over here. See this. To simplify this whole calculation can be simplified in a simple Snell's law, and that is called as vector equation of Snell's law. So to do this whole calculation, instead of doing that much of typical calculation of such steps, we can devise this whole equation into vector form of Snell's law. What does it tells? See this. What does it tells? That if, let's suppose, if you have incident ray represented by unit vector I cap, I represent the normal by unit vector n cap, then I represent the refracted angle by r cap or refracted light by r cap unit vector, and then this normal will be also represented as n cap. So what does vector form of Snell's law tell? That if I take the cross product, if I take the cross product of which vectors, if I take the cross product of incident vector with respect to the normal vector, and if I multiply with the refractive index, let's suppose this is lying in the medium 1 and this is medium 2. So refractive index of medium 1 is mu1, refractive index of medium 2 is mu2. Then what is the given value? That mu1 into cross product of I and normal, means the direction of incident ray and normal, is going to be equal to mu2 into cross product of r cap and normal. You try to observe over here why this equation is given. Why this equation is given? To try to see this, I can write this as what? Mu1 into magnitude of I cap into magnitude of n cap into what should be sine of angle between them or not. So sine theta I, that is equal to what? Mu2 magnitude of r cap magnitude of n cap into sine of what, guys? Sine of theta 2. So what you got over here? Did you got your Snell's law equation? Mu1 of sine theta 1 and or sine theta I is equal to mu2 of sine theta r. Got it or not? This is your which equation? This is your equation for the Snell's law. So this is why we are trying to represent the whole this mu1 sine theta 1 and mu2 sine theta 2 in terms of vector form of Snell's law. What does it say? That cross product of incident ray and the normal multiplied in which medium it is going to lie must be equal to the refractive index of medium or product of refractive index of the medium and the cross product of refracted ray with the normal. Are you able to get me or not? Yes or no? Yes. Gagan, Anuj, yes or no? Yes, sir. Okay. So this particular thing will help you to solve. See, this whole typical this here, as it was very doing, it is very cumbersome. So what we do it, like let's suppose if in the question incident ray equation is given, if in the question normal equation is given, if in the question refraction equation is given, if and normal equation you are aware of it, then you can directly calculate using this. Or if you are only aware of incident ray, see if you what I was aware of my incident ray. What was it? 6 root 3. What was given? 6 root 3 I cap plus 8 root 3 j cap and minus 10 k cap. Okay. And this was my incident ray vector. I need to convert it into unit vector. So a vector or I cap is represented as what? Vector A divided by magnitude of vector A. So this will be equal to how much? 6 root 3 I cap plus 8 root 3 j cap minus 10 k cap divided by, if you calculate the magnitude, how much it is going to be? It is going to be root over 400. Okay. Now if you got the incident ray vector, you are aware of this normal vector. This normal vector is what? According to the previous question, this normal was equal to z or k cap. Yes or no? Plus k cap. Okay. Now you can you calculate easily or not? You calculate even theta you calculated, this was equal to how much? It was equal to 60 degree. And even it is not required. If you are even not aware of this, you can apply this formula and you can get the answers. Mu1 mu2 sin theta is sin theta 2. It was equal to 60 degree, and you can know theta 2 out of it, that was equal to 45 degree, and from here you can directly calculate the answers. Yes or no? So this is easiest trick or not? Tell me yes or no. Anuj, Gagan, Himanshu. Yes, sir. Are you able to get me? So these kind of questions will be asked in your exams to how to form the vector equation of refracted ray, how to form the vector equation of incident ray. We can try to get through these equations. Okay. So based upon this was a whole of vector form of Snell's law. Okay. Now we know that what we got to know, little bit of digression of all of these things. What is that? That simple, if light travels from one मीडियम टू अनदर मीडियम, मतलब अगर लाइट एक मीडियम से दूसरे मीडियम में जा रही है भैया, ठीक है ना, तो हम उसकी दो प्रॉपर्टी याद रखते हैं. फर्स्ट, फ्रीक्वेंसी रिमेन्स कांस्टेंट. सेकेंड पॉइंट, वेलोसिटी. अगर मान लो मीडियम 1 is having less refractive index as compared to medium 2, what will happen? Velocity decreases, and as the velocity decreases, wavelength also decreases. Got it or not? Why? Because your frequency remains constant. Second point, that Snell's law tell that mu1 sine theta 1 is equal to mu2 sine theta 2. On which principle it is based upon? Similar velocity principle. Okay. Or law of conservation of energy for the light. Similar velocity or law of conservation of energy for light. Are you able to get me or not? Yes or no? Now, based upon this refraction principle, based upon this Snell's law, we can form the vector equation of Snell's law and we can write the equations for it. Okay. So this was all about your vector equation of Snell's law. Based upon this, tomorrow, what I'm going to complete this total internal reflection for different cases. Okay. So there are 2 to 3 different cases for which I will complete this total internal refraction. And after that, I'll solve some kind of 20 to 25 problems based upon this refraction and this total internal refraction. Are you able to get me or not? Yes or no? Okay. Gagan, कोई दिक्कत? Okay. 1 minute. I'm just stopping the recording, stopping streaming also.